Okay, next question.
This question comes to us from Joe Hastings from Pretoria. Everything in shadow is unbelievably cold, but if it's not, then it's unbelievably hot. And what happens if you're half in the shadow and half not? Like, let's say you're in the shadow and I'm in the light. What's that going to be like if we're one person and half of us is like this?
I'm going to be really cold.
And I'm going to be really hot. But if we're one person, does that mean like my left hand is hot and my right hand is cold?
I think so.
I think it could really be that way. Maybe in the middle, I'd sort of be a mixture of both, but I'd be worried about these fingers being cold and these fingers being hot.
And it's due in part because there's no atmosphere, you're in space, right? And there's no transfer of heat between the shadow and the brightness due to the mechanisms we have on the surface of Earth. And so if you're in shadow, you get really cold because you don't have any sun energy hitting you. If you are in the sun, then you've got all that solar energy hitting you and you get really hot. And the temperatures that we typically see are minus 100, 150 centigrade in the shadow, and maybe plus 150, maybe as high as 200 centigrade in the sun.
But first, before we leave this one, let's talk about light and dark and what it's like for us on the space station in terms of how often is it night and how often is it day?
Oh, 16 times.
Exactly. So like, let's say, this is the Earth and we're going around it. Let's say I'm the sun, right?
Okay.
So on this side of the Earth, it's going to be hot and sunny.
Right.
So when we're here, we're hot and it's light out. And then 45 minutes later, it's dark, it's cold, and now it's hot.
And that's because
bright.
it takes us 90 minutes to go around Earth. So about half of that, actually a little less than half of that, is behind Earth. So you're in dark. And then a little more than the half of that, you're sunlit. And so you see 16 sunrises and sunsets every day.
So we need to make sure we design our spaceships and our space stations and our space suits to be able to be both hot and cold. And again, now we're talking engineering and science.
Yeah, and that takes math.
It's true.